Hello friends, so as you can see from the video, today I am going to teach you the basic working of the insertion sort algorithm. Now, the insertion sort is one of the most simple sorting algorithms. It works by sorting one element at a time. It is less efficient when compared to other algorithms such as quicksort and radix sort, but when you compare its simplicity, you can easily understand the algorithm and it is much simpler to implement than the quicksort and radix sort algorithms. So these are the basic technique and basic steps of insertion sort. Any array is divided into two sets. One is the sorted values and one contains the unsorted values. So each top value from the unsorted array is taken and inserted into the proper sorted array position. To save space, most implementations use a single array. You can also use two arrays, one for unsorted elements and one for the sorted elements, but this leads to greater usage of memory. Hence, to save memory, most implementations use only a single array. So this is an example, an array of 8 numbers, and we will sort this array using the insertion sort algorithm. Now the main point is that the first element in any array is always treated as being in the sorted position. So as you can see from the video, the blue colored array indicates the elements which are already in the sorted array, and the orange colored elements indicate that the elements which are an unsorted array, and these elements need to be sorted and inserted into the sorted array. So by default 315 is taken to be in its sorted position. Now we begin an actual sorting process using the insertion sort algorithm. Remember, blue is for the sorted array and orange is for the unsorted array. So we take one element from the unsorted array which is at the front of the unsorted array and insert it into its proper position in the sorted array. So as you can see, 221 is at the front of the unsorted array. We take it and insert it into its proper position in the sorted array. As you can see, 221 is less than 315, so it will be inserted before 315 in the sorted array. The blue arrow indicates the currently swapped element and the orange arrow indicates the element which will be swapped next, or rather which is at the top or at the front of the unsorted array. Next is 123. 123 will again be inserted into the sorted array. So here it is, we have inserted 123 into its proper position. Since it is less than 221, it will be inserted before 221 in the sorted array. Next is 886. Since 886 is already greater than 315, it will directly be inserted into the sorted array. Next, 796. Again we have inserted it into the sorted array. Since it is less than 886, we insert it before 886 into the sorted array position. Next, 286, we insert it before 221 and 315. Next is 889. Since as you can see from the video, it is the greatest element, it will stay where it was and will be directly inserted into the sorted position. The last but not the least is 105. Since as you can see from the array, it is the smallest element, it will be inserted at the beginning of the sorted array, and so here it is, we have sorted the entire array. So this is how an array can be sorted using the insertion sort algorithm. We simply have to pick an element from the unsorted array and directly insert it into its proper position in the sorted array. Now there are a few important points to remember. Any array which needs to be sorted is always divided into two parts, a sorted elements and unsorted elements. From the unsorted elements, each single element are handled at a time and inserted into the sorted array in its proper position. Now, two arrays can also be used as I have said earlier, but it leads to a greater usage of memory. So most implementations only use a single array and perform the swapping of elements inside the same array. Remember, you always need to take an element from the unsorted array and directly insert it into the sorted array in its proper position. So this is the conclusion. It is easy to implement. The insertion sort algorithm works fast on small data sets, works better on substantially sorted algorithms. It can perform sorting at runtime and consumes less memory. The less memory depends whether you are using a single array or two arrays for performing the sorting operation. Thank you. Please do like, share and subscribe to the video if you have enjoyed watching. Here are few of the other videos from my channel. If you do like watching the videos, please do view these videos as well. Thank you.